So in our last lesson we learned how to graph quadratics, and today we're going to take it one step further and use those graphs to actually solve quadratics. Our normal quadratic is going to look like y equals ax squared plus bx plus c. And what we're going to do today is we're going to solve quadratics of the form 0 equals ax squared plus bx plus c like we've done before. Typically, we've gone ahead and factored these and then found the answers. Today, we're going to tie in how those answers correlate to our graphs. Well, it turns out that those answers are actually, if we set y equal to 0, our x-intercepts. So you'll notice here we have an option where we have two solutions or two x-intercepts for our graph. And we also could have two x-intercepts if the graph was going up like this. So those x-intercepts are going to be the factors of that quadratic. If we have one x-intercept, it could either be an upwards opening parabola or a downwards opening parabola like this. But one x-intercept would be one solution to that graph. And if we have no solutions that we can find for that graph, or no x-intercept, then there would probably be no way to go ahead and factor that graph. Solutions for a quadratic are also called roots, and sometimes they're also called zeros. Our book's going to use roots. So let's go ahead and use our graphs to actually find these factors. So our first equation is 0 equals x squared minus 2x minus 8. If I want to find the x-coordinate of the vertex, we would take and go negative b over 2a, so that's the 2 over 2 times 1, which equals 1. And then we want to find f of 1 to get vy, and that's going to be 1 minus 2 times 1, that's actually 1 squared, minus 8, which is negative 9. So I have a vertex of 1 and negative 9. I also know that I have a parent function of y equals x squared, which goes 0, 0, 1, 1, 2, 4, 3, and 9. So moving over 1 and down 9 puts me here. Then if I move 1 over and 1 up, I get a point, 2 over and 4 up, I get a point, and 3 over and 9 up, I also get a point. Now, knowing also that my axis of symmetry is going to go through that vertex, then I can move over 1 in the other direction and up the same amount, over 2, up the same amount, and over 3, up the same amount, and I notice here is my parabola that happens to have x-intercepts at negative 2 and 4. And notice if I factor this quadratic, 0 equals what multiplies the negative 8 adds the negative 2, that's x plus 4, x minus 4, and x plus 2. Using the zero product principle, x minus 4 is equal to 0, and x plus 2 equals 0, so x equals negative 2, and x equals 4. So there's our graph showing that our x-intercepts are negative 2 and 4, and checking by factoring, we get the same solution to that graph. So let's take a look at this next quadratic. I have x squared plus 8x plus 16 is equal to 0. Again, I'm going to take and find my coordinates of the vertex by taking negative b over 2a, giving me a negative 4 vy. I'll get by plugging this negative 4 back into the quadratic, so that's negative 4 quantity squared plus 8 times negative 4 plus 16. This gets me 0. So I have a vertex of -4 and 0, which is kind of convenient. -4 and 0 happens to be here. And from this, we know we have y equals x squared as our parent function. 0, 0, 1, 1, 2, 4. Over 1, up 1. Both directions. Over 2 and up 4. We see that this has only one x-intercept. So when I factor, 0 equals x squared plus 8x plus 16. Should be no surprise that I look for two numbers that multiply to 16 and add to 8, and that's 4 and 4. So the zero product principle says x plus 4 has to equal 0 and x equals -4. And so there's our singular solution. In this case, I want to take and graph once again. I notice, let's go backwards this time. Actually try to factor first. I get x, and what two numbers multiply to 3 and add to 2? Well, it's not going to happen. So I'm assuming, since I can't factor, that this parabola is not going to have an x-intercept. So let's go ahead and take a look by finding the x-coordinate of the vertex, taking -d over 2a, getting -1. And v sub y is going to equal -1 squared plus 2 times -1 plus 3 gives me 1 minus 2 plus 3, or 2. So I have vertex, -1 and 2, y equals x squared. It's my parent function, 0, 0, 1, 1, 2, 4. Here's -1, 2, over 1, up 1, over 2, up 4, etc., etc. Clearly see this parabola is not going through the x-axis at all, so there are no x-intercepts, therefore no solution. Now we're actually going to use a calculator to find the solution of this quadratic, because again, there's nothing that multiplies to a +2 and adds to -4, so does that necessarily mean that there are no x-intercepts, or does it mean those x-intercepts aren't nice clean integers? Well, let's find out. So here's our calculator. I want to go to the y equals portion of it. Now I'm going to plug in x squared, so x squared minus 4x plus 2. And I'm going to graph that in my standard window. But before doing that, I'm also going to graph 0 and go ahead and hit zoom 6, because that's my standard window. And we get something that looks like this. So you can clearly see there's two x-intercepts, but they don't appear to go through nice integer spots. But we can find out an approximate value of these by finding intersections with the line y equals 0, which is this horizontal line going through the x-axis. So what I'm going to do is I'm going to hit second and this trace button, and right above that you see where it says calculate, and it says intersect. So I'm going to hit the number 5, or I could also go down to intersect and hit enter, and it'll say first curve. Well, that's part of the parabola, so I'll look at that, and it'll pick the second curve, which is the line going across. And then my calculator will ask me for a guess, so I'm just going to hit enter a third time. And it finds the closest intersection point of the parabola in that straight line, which is about 0.59. And then we go back and we say, okay, well now what we're going to do is we're going to second calculate again the intersect, so I'll hit 5. And they say first curve, which is my parabola. So I'm going to go over towards the second y-intercept, or sorry, x-intercept, and hit enter, and then hit enter again. It'll ask me to guess, so I hit it a third time. I end up with about 3.4. So those are my two values. Now, unfortunately, because this doesn't actually factor, I can't check it by going ahead and factoring, so I just use these as my two solutions. So now we've got a word problem talking about the path of a rocket ship and its height over a period of time given by the following equation here. And they want to know about how long this rocket ship was in the air. So if we graph this, I'm guessing it's going to look like this. Starts from the ground, goes up, and then comes back down. So again, we want to know how long it's been in the air. We need to find its x-intercept over here. So we're going to use our calculator again and move it down just a little bit. Well, maybe I won't. So in this, we're going to go back to y equals. We'll clear this out of here. Our equation was negative 16t squared, so negative 16 x squared, because the calculator won't do t's, plus 250 x. And what I want to do is I want to graph that. Well, if we graph this in our normal window, we could go zoom 6 and see what that gets us. Now, so I just hit enter, and it's apparently graphing, but I can't see a thing on my screen. So what we're going to have to do is we're going to have to adjust our window a little bit. Now, if I look at that window, I'm asking for x to be between negative 10 and 10. Well, that doesn't make a whole lot of sense because we're looking at negative time. I don't need to look all the way back to negative 10. In fact, I think I'll just go to negative 1. And then clearly we don't see it coming down in 10 seconds. So let's just go to 50 and see what that does for us. And then clearly, if we look at our equation and say at time 1 second has passed, after 1 second this is negative 16 plus 250. So you would think that it's going to be a little less than 250 tall. Well, given that, I'm not going to see that if my y value is up only to 10 high. So I'm going to move that. I'll move that to 300 and see what happens. And then I'm going to hit graph again. Now you'll notice I see my rocket go up, come down, but I don't see its highest point. If I want to see the highest point, I'm going to have to adjust the window more. So let's go ahead and do that. We also notice that it's coming down about in half the time of the 50 we used before. So I'm going to adjust that as well. Let's put that at about 30. And I'm going to need to look higher to see its highest point, even though my problem's not asking me for that. So I'm going to double that and go to 600 and see what I get. So here we go again. And I must have plugged something in wrong because this looks kind of off. So I'm going to go back to my window and see what happens. And sure enough, my x max is only 3. So I'm going to make that 30. And again, something happened to my y max. I wanted that to be 600. So I'll graph that now. And again, you see it go up, come back down, but you don't see its full height. If I want to see its full height, I'm going to make that y max about 1,000. I should be able to see it then. That's 10,000, too much. And now, at 1,000, there we see its full height. But what I really want to know is what this x-intercept is here. So again, what I'll do is I'll go back to look at my two equations, make sure I have 0 as my second equation, and then go to calculate the intersection. And the first curve is going to be the parabola. Second curve is going to be the line down here. Hit enter. Guess. Hit it again. And it appears it's been up in the air 15.6 seconds. And that corresponds to that amount of time right there. So this is all we've got. Again, we could have found these answers simply by factoring, but now we're tying this into the x-intercepts of the graph of this quadratic are the same thing as the roots of the equation or the solutions of a factored quadratic. So answer these two questions, make sure you write your lesson summary. We'll get back to you tomorrow.